So, what if you could give a construction drone a creative brain? Well, researchers at Carnegie Mellon University have pretty much done just that. They've created a system called LLM-Drone, and it combines a powerful AI, a large language model, with the go-anywhere freedom of a drone. And let me tell you, it might just completely change how we build things. Just think about it for a second. Imagine a natural disaster hits, and you need to get emergency shelters up in some remote, totally inaccessible area. Or maybe you need to repair a bridge way up high over a canyon. What if you could just send in a swarm of autonomous drones to literally 3D print the whole structure right there on the spot? Now, on the surface, drones seem like the perfect tool for a job like this, right? They can fly almost anywhere. But the second you try to attach a building tool to them, you run smack into a really frustrating roadblock.
We can call it the shaky hands problem. And it's the #1 reason why drone-based 3D printing has, really struggled to get off the ground.
The official name for this is aerial additive manufacturing. And the idea is simple. Use drones to build stuff layer by layer, kind of like a flying 3D printer. But here's the huge catch. Drones are fundamentally unstable. They wobble, they drift with the wind. Trying to print a super precise line from a shaky drone, it's like trying to write your name with a pen during an earthquake. It just ends in a complete mess. So, to get around this, the researchers had to completely rethink the whole process. Instead of trying to make the drone's hands steadier, they decided to give it a way smarter brain. And this right here is the big leap. The old way of squirting out material just doesn't work because of the instability. The new idea has two parts. First, forget the messy goo. The drone just picks up and places simple magnetic blocks. And second, and this is the genius part, a large language model acts as the AI brain. It doesn't just create a plan, it can adapt that plan on the fly.
You should think of the LLM as a super creative project foreman. You give it a simple text command like, hey, build cross, and boom, it spits out the step-by-step coordinates for the drone. But its real magic is what happens when things go wrong. If the drone messes up a placement, the LLM doesn't just crash. It looks at the mistake and comes up with a whole new plan to get the job done.
So how does this whole thing actually work together? Well, the LLM drone system is broken down into 3 key parts that acts as the system's brain, its eyes, and its hands. Okay, first up, you've got the planner. That's the LLM. It takes your text prompt and dreams up the blueprint. Then you've got the eyes. This is a computer vision system that's constantly watching the build site. It helps the drone know where to go, checks if a block was placed correctly, and if it sees a mistake, it tells the planner. And finally, you have the hands. That's the drone itself with its magnetic gripper, physically putting all the blocks together. And this ability to not just spot, but creatively solve real-world mistakes is what makes this whole thing so incredible. I mean, it's one thing to follow a perfect plan, but it's something else entirely to know how to fix things when they inevitably go sideways. But which AI actually makes for the best architect? The researchers put a few of the top models to the test on their spatial reasoning skills. They measured how good they were using something called intersection over union, or IOU, which basically scores how perfectly the AI's plan matches the target design. And as you can see, Claude 3.5 Sonnet was the clear winner, with almost 90% accuracy. Just fantastic.
All right, so let's walk through a real test. The user gives a simple prompt, build a cross. The LLM, our planner, gets to work and generates a perfect symmetrical set of coordinates for the drone to follow. So far, so good. Everything's going according to plan. But then the real world happens. A little gust of wind, a tiny error in positioning, and the drone puts a block in the wrong spot. For any other robot following a rigid script, this is game over. A total failure. Mission aborted. But this system, it's different. As the researchers themselves put it, the LLM showed creative adaptations. It didn't just give up. It dynamically revised the whole plan, finding a new path to success by working with the error, not fighting against it. And this is just a brilliant illustration of how powerful this is. The computer vision eyes see the misplaced block. They feed that new info back to the LLM brain. The LLM looks at this new reality and goes, okay, no problem. I can still make a cross. I'll just have to rotate the design by 90 degrees. It whips up a new plan, and the drone gets right back to work, finishing the job perfectly. So what does all this add up to? This combination of smart planning and automatic error fixing is just incredibly effective. Across all their tests, the LLM drone system nailed a final build accuracy of 90%. That is a massive leap forward for any kind of aerial construction. So, what does this all mean for the future? Well, this research is way more than just a cool lab demo. It's really a proof of concept for an entirely new way of building things. And the team has a pretty clear roadmap from here. The next big steps are to get this system out of the lab and into messy, real-world outdoor environments. They want to start building more complicated, multi-layer 3D structures, not just these flat 2D patterns. And to do that, they'll need to upgrade the hardware. We're talking bigger drones that can carry more weight and smarter electromagnets for even finer control.
In the end, what this research really does is redefine what a plan even means for a robot. It's no longer just a rigid, step-by-step list of instructions. It's a flexible goal. And that leaves us with one heck of a question. When a robot can creatively fix its own mistakes, what can't we build?